Organometallic reagents that come from organolithium compounds or Grignard reagents, these are strong nucleophiles, but they're also very strong bases. So if you take some R- and you put that in the presence of a protic source like an alcohol, just do a simple HOR prime, this is going to very rapidly react in an acid-base reaction. You're just going to protonate your carbon. So you form the RH bond plus O-. So that acid-base reaction is incredibly fast. So if you think about the reaction like I've shown below, and we take this starting material and add phenylmagnesium bromide to that, and I'm actually going to leave out the second step for right now for the purposes of our discussion. If we add phenylmagnesium bromide, what we're effectively doing is adding pH minus. Now, what we want is for this nucleophile to add to the carbonyl. So let's write what we desire. So we desire to add it like this, and then after the acidic workup, we protonate and get the OH. But if you do this reaction, what happens instead is just an acid-base reaction. So instead, that phenyl minus will deprotonate the alcohol oxygen. So effectively, what we need to figure out how to do is find a way to essentially protect this alcohol from the acid-base reaction so that we can do the desired nucleophilic addition to the carbonyl. And there is a way to do that. We can use something known as an alcohol protecting group. So what we're going to do is protect the alcohol, do the desired reaction, and then deprotect the alcohol. So let's start with the protection. The reagent we use for this is some trialkyl silyl chloride and base. And this is our protection step. So that's our step one. What this does is it replaces the hydrogen on the alcohol with the SiR3. Now that that oxygen no longer has a proton, we can do the Grignard addition. So we'll add the Grignard reagent, follow it by the acidic workup. So step 2 is our desired reaction. Okay, now finally we need to get our original alcohol back. So we'll do step 3, which is a deprotection. And we deprotect using fluoride, F- and water. And the byproduct of this step is a trialkyl silyl fluoride. The driving force behind this is a very strong silicon-fluorine bond. Just to give you an idea of a couple of common reagents used for the protection and deprotection, the R3 SiCl is often TMS chloride, which is trimethyl silyl chloride. But there are certainly others. A common base for this reaction might just be triethylamine or pyridine, usually an amine base. And then the fluoride source isn't just as simple as adding like sodium fluoride. The common fluoride source for this is called TBAF, which is tetrabutyl ammonium fluoride. And what that looks like, it's a nitrogen with 4 butyl groups. So that's the ammonium, so the tetrabutyl ammonium, and the fluoride is the salt. So these are more specific reagents, but really I just want you to understand the basics of how you can protect an alcohol to do this type of desired organometallic addition.